All right, so number 11 says we have to find the interval of convergence of the following power series. So what I do is I make a couple of statements. I'll say let an be equal to the 3x minus 2 raised to the power of n over n times 3 to the n. Okay? Now, because we will essentially need to apply a ratio test because the absolute value of an plus 1 over an must always be less than 1 for it to converge, then let me just write out what my an plus 1 is. All right, so an plus 1 means that wherever I see an n, attach n plus 1. So we have 3x minus 2 raised to the power of n plus 1 divided by n plus 1 times 3 to the power of n plus 1. Now, if you would like, you can simplify the an plus 1 just a tad bit or expand it out. So that way, when you do apply your ratio test, it makes easier for cancellation purposes, right? So for example, that numerator, 3x minus 2 raised to the power of n plus 1 is really 3 to the x minus 2 times 3x minus 2 to the n, right? As long as you're if you notice, you're applying the power rule for exponents backwards. As long as the bases are same, you can add the exponents. So you can basically split your exponent here as a product of your base raised to one of the powers times your base raised to the other power, right? So our powers here were n and 1 respectively. Now in the denominator, you can do the same thing. You leave n plus 1 alone, and you can multiply now by 3 times 3 to the n. Okay? So, or you could just leave that as 3 times 3 to the n like this. Right? All right, so now let's apply that ratio test. So what the ratio test allows us to do is to say that, okay, if I compute the limit as n approaches infinity of an plus 1 divided by an, this ratio, in order for us to have convergence, must always be less than 1. Now, I know what my an plus 1 is, and I know what my an is, so I'm going to make a substitution. We'll have the limit as n approaches infinity of an plus 1, so that will be the 3x minus 2 times 3x minus 2 to the n divided by n plus 1 times 3 times 3 to the n divided by an. So an was 3x minus 2 to the n over n times 3 to the n. Okay, so instead of dividing by an, you now multiply by its reciprocal. So this will give us the limit as n goes to infinity of 3x minus 2 times 3x minus 2 to the n over n plus 1 times 3 to the n multiplied by n times 3 to the n, and then 3x minus 2 to the n. So here, the things will start canceling out. For example, 3x minus 2 to the n cancels, 3 to the n, and 3 to the n also cancels. All right. So this will now give us, I'm going to write it out here on the side, the limit as n goes to infinity of 3x minus 2 times n over 3 times n plus 1. So I just rearranged the terms in the denominator. Okay, so the part that's now significant for us is going to be the n times n plus 1. What I can do is factor out everything else. If I pull everything else out, including the absolute value, we'll have the absolute value of 3x minus 2 times divided by 3 multiplied by the limit as n approaches infinity of n over n plus 1. But you should recognize what this limit goes to. what would this limit go to? N over n plus 1. Not infinity, careful. It goes to 1 since the degree of your numerator and denominator are the same. So we have, this is going to be 1 times the absolute value of 3x minus 2 divided by 3. Now, when you multiply these two things together, you're still going to get the absolute value of 3x minus 2 over 3. But now just remember, in order for you to have convergence, that absolute value has to be less than 1. Now, if you want to rewrite it as an interval, this is now the same thing as negative 1 is less than 3x minus 2 over 3 less than positive 1. So now what you're going to do is rewrite this inequality where the middle is just going to be x. So what I can do is first multiply the entire inequality by 3. So this will give me negative 3 is less than 3x minus 2 less than 3. Then I could add 2 to both sides. So we'll get negative 1 again, less than 3x, which is less than 5. Because I had to add 2, so 3 plus 2 is 5. And now I divide by 3. So we get negative 1 over 3 is less than x, which is less than 5/3. So this is now going to be your interval of convergence. What I know from this inequality is that, okay, here's my left endpoint, here's my right endpoint, negative 1/3, here's 5/3. I know that anything now in the middle here, we're going to have convergence. Right? Whatever I shaded in blue is convergence. But the thing is now, is what about your endpoints? So when x is equal to negative 1/3 and x equals 5/3, you need to plug them into the original series, the given series, and then use some other series tests to determine whether or not you have convergence or divergence. So let's check it out. When x is equal to negative 1/3, we will have the series from n equals 1 to infinity of 3 times negative 1 over 3 minus 2 to the n power over n times 3 to the n. Now let's take a look at this part. 3 times negative 1/3, right? Just doing this aside here. 3 times negative 1/3 is negative 1. And no, I'm sorry. Was it negative 1/3? Yes, it is negative 1/3. 1 sec though. Hold on. Is there a slight mistake? Let's see. We multiply by 3. Then add 2. Give me 1 second. There might be a mistake somewhere. Let's see, 1/3. No. So I'm trying to figure something out here. Because if I do 3 times negative 1 over 3, that's negative 1. Negative 1 minus 2 is negative 3. But I don't want negative 3. Oh, no, that's fine. I think I could have the negative 3. That's okay. Yes, this is negative 3. I'm right. Okay. So, sorry about this. I'll continue. So in the numerator, you will have negative 3 to the n power over n times 3 to the n. Now, what you can do here is rewrite the numerator as negative 1 to the n times 3 to the n, all divided by n times 3 to the n. So what happens to my 3 to the n? My 3 to the n's will cancel out, and now I have the following series. Negative 1 to the n power over n. Now, how can I check whether this series now would converge or diverge? Which test do you think I'll use here?
Alternating series.
There you go, Preston. We'll use the alternating series. So the first thing is you will label your an. So you'll say let an here be 1 over n. Now, if you compute the limit as n goes to infinity of 1 over n, that limit is 0. And if you look at the sequential terms, it is decreasing, right? Your an will equal to 1, right? If n is equal to 1, then you get 1/2, 1/3, and so forth. So it is decreasing. So by the alternating series tests, we have convergence at x equals negative 1/3. So what I'll do is I'll shade in my negative 1/3, and now I just have to check the other endpoint, check the 5/3. Well, when x is now equal to 5 over 3, we'll get the series from n equals 1 of 3 times 5/3 minus 2 raised to the n power, all divided by n times 3 to the n. But if you look at the numerator, 3 times 5 over 3 is going to be 5. So 5 minus 2 is 3. So we get 3 to the n on the top. So this is equal to 3 to the n over n times 3 to the n. Well, 3 n's will cancel, and you will have the following series. N equals 1 to infinity of 1 over n. Now, what does this series look like to you?
Harmonic.
It's a harmonic. This is the harmonic series. And what do we know about the harmonic series?
Doesn't it converge?
Careful. Harmonic
It
series
diverges.
diverge.
The
Sorry,
limit is
diverges.
0, but it diverges.
Yeah, it diverges. We know that the endpoint 5/3 is not included, so your final solution will be in interval notation. We're including the negative 1/3, so I need a square bracket. So negative 1 over 3, comma 5/3, open parentheses. This is your
Excluded, basically.
yeah.
Gotcha.
This is your interval of convergence.
So the reason it diverges, right? Even though the limit is